Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, paper 2, variant 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics and also you can have better understanding of these questions. Let's study together, let's improve together. In today's lesson, we are talking about May June 2023, paper 2, variant 2. Total time for this exam is 1 hour and 15 minutes and you need to answer all questions on this paper. And total mark for this paper is 60. On second page of exam paper, important data and some important and basic formulae are given. If you need value of any constant or you need any formula, you can come to second page of your exam paper. Question 1 part A says define pressure, and pressure is simply equal to force over area normal to the force. So we can define P means the pressure, this is equal to force over area normal to the force. So very important to mention that area normal to the force, area normal to the force. So this is how you can define pressure, and this question has 1 mark. If you have written this one, you will get 1 B mark. I mean, this one has to be in your answer. For the second part, we need to use the answers from A1 to show that SI base units of pressure are kgs per meter per second square. So simply we can rewrite P is equal to F over A and force F is equal to MA divided by area normal to the surface. This is area normal to the surface. SI unit for mass we have kgs, and for acceleration we have SI base unit meter per second square, and for area we have meter square. Now we can simplify this one. We can cancel this meter with this power, so we left with kgs per meter per second square. And this question also has 1 mark. If you have derived this one, you will get 1 mark. So this one should be the answer mark. Part B says a horizontal pipe has length capital L and a circular cross section of radius capital R. A liquid of density rho flows through the pipe. The mass m of the liquid flowing through the pipe in time t is given by this equation, where P1 and P2 are the pressures at the ends of the pipe and K is a constant. Determine SI base units of K. Is a typical type of question. Most of the time in exam they will ask you to determine SI base units for any quantity, and in SI base system we have 7 SI base units and we have 7 SI base quantities. For this question we need to determine units of K, so we can make K the subject. So we can write down pi, and here we have P2 minus P1, so simply we can write down here this is the delta P, and here we have this is R, and here we have rho, and here we have T, and this is divided by 8m times L. Now if you look at SI base units, pi is a constant and it has no units, so pi has no units. 8 also is a number, it also has no units. For delta P, we have already determined SI base units for P. SI base units for P are kgs per meter per second square, so we can write down SI base units for pressure, and R is a radius and SI base unit for radius is meter, and the power of this one is 4, so this is meter to the power of 4. Density, SI base units for density are kgs per cubic meter, and for time we have seconds. And for mass we have m is the mass, SI base unit is kg, and for length SI base unit is meter. Now we just need to simplify. First of all, in this case you can see we have kg here and we have kg here, so kg cancel, so we left with 1 kg in numerator, so we can write down here we have 1 kg. Now we can look at meters, so here we have meter and this is 4, so we left with 3 here, so we have 3 here and we have 3 here, so these two they will cancel each other. So we only left m to the power of -1. Now if you look at s, we have s to the power of -2 and s to the power of 1. So simply we have s to the power of -1. So these are SI base units for K. So simply you need to write down kgs per meter per second. Simply also you can write down in this form. So this is our final answer, and this question has 3 marks. The first mark you will get if you have written these individual units. So you will get 1 C mark, and other C mark you will also get if you have written the units for density. You will get 1 C mark here as well. So you will get 2 C marks if you have written this part of the question, and the last mark is the answer mark. If you have got the right answer, you will get 3 marks. Part C says an experiment is performed to determine the value of K by measuring the values of the other quantities in equation in P. The values of L and R each have a percentage uncertainty of 2%. State and explain quantitatively which of these two quantities contributes more to the percentage uncertainty in the calculated value of K. So we need to determine the percentage uncertainty for K. If we rearrange this equation, we can simply write down K will be equal to pi P2 minus P1. So we can determine delta P, and here we have R to the power of 4, here we have rho, and here we have T, and this one will be divided by 8 times M times L. Now we can write down how we can determine the percentage uncertainty in K. So simply here we can say percentage uncertainty in K, this one will be equal to percentage uncertainty in R. We can say percentage uncertainty in R, but the power of R is 4, so it has to be multiplied by 4, plus percentage uncertainty in delta P, percentage uncertainty in delta P, plus percentage uncertainty in rho, percentage uncertainty in rho, plus percentage uncertainty in T. Means simply we have to add the percentage uncertainties of all these quantities together, plus percentage. 8 is a number, so it should be ignored when we calculate percentage uncertainty. So we have to add percentage uncertainty in M plus percentage uncertainty in L. So if we have these percentage uncertainties, simply we need to add all these percentage uncertainties together when we need to calculate percentage uncertainty for a quantity like K, because other quantities, they are divided and multiplied, so the percentage uncertainties have to be added. But for this question we only have percentage uncertainty for R and we have percentage uncertainty for L. So here we can write on here 4, and percentage uncertainty in R is 2%, plus, now I will be just writing this one because we don't have percentage uncertainties for these quantities, plus we have percentage uncertainty in L. L has no power, so this is percentage uncertainty in L is simply 2%. So this is 2% for L, and rest of these means this one plus this one plus this as it is we can write on. So simply here we don't have percentage uncertainties for them, so if we have, we can simply plug in these 4 percentage uncertainties here to calculate the percentage uncertainty in K. So simply we need to compare which one is contributing more to the percentage uncertainty of K. So in this case R is contributing more, so R is contributing more because this one is 8%, so R is contributing 8% and L is contributing only 2%. So this is R and this one is L. So simply we can say R contributes, so we can write on here R contributes 8%, so we can write on here 4 times 2%, so this is 8%, and L contributes only 2%, and L contributes 2%. So R contributes more. So R contributes more to the percentage uncertainty, contributes more than L. So this is how you can write down your answer. And this question has only 1 mark. If you have written this and you have explained, you will get the 1 mark, and that is the answer mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2023, Paper 2, Variant 2. In this lesson, we will try to cover all the remaining questions about mechanics from this paper. And we will discuss these questions in detail so you can improve your conceptual understanding of ES Physics, and also you can have better understanding of these questions. In order to get maximum benefit from these videos, always pause the video, do questions by yourself, and then compare your answers with my solution to get maximum benefit out of these videos. And this is a practical way of learning from video lectures. Let's study together, let's improve together. Question 2, part A says, state what is meant by the center of gravity of an object. Center of gravity of an object is the point where if we apply a single force, we can balance that object, and that point is called center of gravity. Means at that point we can consider whole weight of the body is acting. For example, if I look at this marker, you can see it has mass. If I look at this part of the marker, it has certain mass and its weight is acting down. Here weight is acting down. I can take the next part of this marker, certain weight is acting down, and all over this marker. But there is a one special point on this marker where if I apply a single force upwards, I can balance this marker, and that point is called center of gravity. Or for this object we can also say center of mass. Now let's try to find out that point where we can apply a single force and we can balance this marker. So if I apply here, I cannot balance. If I keep sliding my finger, I will reach at one special point, and that special point is somewhere here. So I can balance this marker with one single force, and at that point is center of gravity. So the center of gravity of this marker is lying at this point because I can balance this one with one single force. So this point we call is center of gravity. Let's try to understand this one with the help of this figure as well. So here I have drawn this figure and I will explain you these points again. So first case, I assume that I take only this part of this meter rule. It has certain mass, so it means there is a certain weight that is acting down. And if I take the next part of this meter rule, let's say this part, there is mass, so there is a weight, and I can take next part, there is mass, there is a weight, I can take next part, there is mass. In this piece of meter rule, it has certain mass, so there is force of gravity on that. I can take next part, so there will be force acting downwards. Here force is acting downward, here force is acting downward, weight, and here weight is acting downward. And all these forces I can replace with one single force. Means at this point, if I apply one force that is equal to all these forces, I can balance this one. And that point where I apply one single force, that point we call is CG, that is the center of gravity. Or we can say in this case that is also center of mass. A beautiful point, a special point, very important when we manufacture something or when we design anything. Center of gravity is very important point. Let me show you the answer, how you can write down your answer. So in your answer you can simply mention the point where all the weight of the object is considered to act or is taken to act. That point is center of gravity. Part B says two blocks are on a horizontal beam that is pivoted at its center of gravity as shown in figure 2.1. Part B1 says by taking moments about the pivot calculate tension T in the string. So for this question simply we need to take moment about this point and we need to calculate value of T. So if you look at moment due to the weight of this block, this moment has to be counterclockwise, and moment due to weight of this block, this one has to be clockwise. And tension is acting at an angle, so tension has two components, so we can resolve into two components. It has one horizontal component and it has one vertical component. Moment due to horizontal component has to be equal to 0 because this component of the tension is passing through the pivot, so no moment. But there will be moment due to vertical component of tension and this moment has to be clockwise. Now simply we need to equate because in this case beam is in equilibrium, so the net torque has to be equal to 0, or simply we can say clockwise counterclockwise moments has to be equal to clockwise moments. Clockwise moments means sum of counterclockwise moments has to be equal to sum of clockwise moments. Counterclockwise we have 54 and perpendicular distance is 0.45, and moment due to 2.4, this is clockwise, so we have 2.4 multiply by the perpendicular distance between pivot and the force, that is 0.95. And next one we have vertical component of tension, so this is T sine of 30 degrees, so we can write down T sine of 30 degrees, and the distance of this one is 0.35 plus 0.95, so this is 1.3 meters. Now simply we need to solve for T. If we solve this one for T up to 2SF, our answer will be equal to 34 newtons. So our final answer is 34 newtons up to 2SF. Up to 2SF because the given data is up to 2SF, so our final answer also should be 2SF. And this question has 3 marks. The first mark you will get if you have written this part, you will get 1 C mark, and second C mark you will also get if you have written this equation, and the last mark is the answer mark. If you got the right answer, you will get 3 marks for this question. Part 2 says the string is cut so that the beam is no longer in equilibrium. Calculate the magnitude of the resultant moment about the pivot acting on the beam after the string is cut. So now in this case this string is cut, so no more force by the string on the beam. So in this case we have one block that is placed here, another block we have that one is placed here. So simply we need to calculate resultant moment in this case. So simply we can say resultant moment. Moment due to this block will be counterclockwise, moment due to this one will be clockwise. And counterclockwise moment we will take positive, and clockwise moment we will take negative. And sum of these moments is equal to resultant moment. So moment due to this block will be equal to 54 times 0.45, and this one has to be positive, and moment due to this small block has to be negative because this is clockwise, so we can write on 2.4 here, and this is multiplied by 0.95. Now if we solve this one, our final answer will be equal to 22 newtons meter, and this one is counterclockwise. So this is our final answer, and this question has only 1 mark. If you have got the right answer, you will get this mark. Part C says the beam in B rotates when the string is cut and the small block of weight 2.4 newtons is projected through the air. So it's simply, first of all, we have the block like this. It was tied with a string, and when the string is cut, this beam rotates like this. It rotates like this. So this is what is happening in this case. Figure 2.2 shows the last part of the path of the block before it hits the ground at point Y. At point X on the path, the block has a speed of 3.4 meters per second, means here the speed of the block is given, that is equal to 3.4 meters per second, and is at a height of 1.8 meters above the horizontal ground. So this is the height of this block above the ground at point X. For part C1, we need to calculate the decrease in the GPE of the block for its movement from X to Y. Means when the block moved from X to Y, how much GPE has been decreased. So pretty straightforward question. In order to answer this question, first of all, we can decide over reference line. So this is our reference line, and here we will take H is equal to 0. Now simply we need to calculate decrease in GPE. So we can write down delta GPE. This has to be equal to mg times delta H. Mg is equal to the weight of the block, and weight of the block we have that is equal to 2.4 newtons, and height in this case delta H, this is equal to 1.8 meters. So the final answer is 4.3 joules. So this is our final answer. And this question has 2 marks. The first mark you will get if you have written this formula. You will get 1 C mark, and the second mark is answer mark. If you have got the right answer, you will get 2 marks. Part 2 says use your answer to C1 and conservation of energy to determine the kinetic energy of the block at point Y. At this point, we need to determine the kinetic energy of the block. But we have the speed of the block at point X. Speed of the block was given, that was equal to 3.4 meters per second, and we have height of the block. And in this case, there is no air resistance. Mean air resistance is negligible. So it simply means that total mechanical energy is conserved. So we can say total energy, you can say, or we can simply say total mechanical energy at X has to be equal to total mechanical energy at point Y. And mechanical energy is the sum of kinetic energy plus GPE, means gravitational potential energy. And same for point Y, we can write down kinetic energy at point Y plus GPE at point Y. But for this question, we have already discussed, we have taken ground level as our reference level. Mean at this point we have taken height is equal to 0. As height is equal to 0, it simply means that GPE Y, this is equal to 0. So now simply we can rearrange, we can write down kinetic energy at point Y. This one has to be equal to kinetic energy at point X plus GPE at point X. And for this question, already we have calculated GPE at X. And GPE at X in the last part we have calculated. That was equal to 4.3 joules. We just calculated in the previous part. That was equal to 4.3 joules. So simply we can write down here, this is equal to 4.3 joules. Now simply we need to calculate kinetic energy at point X. We have the speed and we can calculate kinetic energy. Kinetic energy is equal to 1/2 mv square. So this is 1/2, and weight of this block we have, that was equal to 2.4. So we can divide by 9.81. So we can calculate mass, and we have the speed that is equal to 3.4 square of this one, plus we have 4.3. If we solve this one, we will get 1.4 plus 4.3. So the final answer will be equal to 5.7 joules. So our final answer is 5.7 joules. So this is how you can calculate kinetic energy at point Y, and this is equal to the total energy at point X. So this is how we can answer. And this question has 3 marks. The first mark you will get if you have written this formula, means you have used this formula, you will get 1 mark. And the second mark you will get if you have got this value right. So this is C1 mark. And the final mark is the answer mark. If you got the right answer, you will get 3 marks for this question. Third part says state the variation, if any, in direction of acceleration of the block as it moves from X to Y. So acceleration is due to gravity, and only force acting on the block is gravity, and gravity is always acting downwards, and acceleration and resultant force, they are always in same direction. So it means that as direction of gravity is not changing, so direction of acceleration is also not changing. So simply we can say in this case no variation. no variation because acceleration is always in this case vertically downwards. So this is how you can answer. Acceleration is always vertically downwards, and this question has only 1 mark. If you have written this one, you will get 1 mark, and this one should be B mark. Part 4 says the block passes point x at time tx and arrives at point y at time ty. On figure 2.3, sketch a graph to show the variation of the magnitude of the horizontal component of the velocity of the block with time from tx to ty. Numerical values are not required. So for this question, we need to understand, we have discussed already that only force acting on the block is gravity, and gravity is always vertically downwards, and there is no component of gravity along x-axis, along horizontal. So it simply means that as there is no force along horizontal, so the horizontal component of velocity will remain constant. So let me explain you this one with this small diagram. So we have velocity in this direction at point x. It has 2 components. One is the vertical component, so this is Vy, and the other component it has, that is Vx, and Vx remains constant because gravity is only acting vertically downwards. So it means horizontal component of velocity will remain constant. So simply we need to draw horizontal line. So this is how you can draw the horizontal line, and this question has only 1 mark. If you draw this horizontal line, you will get 1 mark. Question 3 says a block is pulled by a force x in a straight line along a rough horizontal surface as shown in figure 3.1. Assume that the total resistive force opposing the motion of the block is 0.80 at all speeds of the block. The variation with time t of the magnitude of the force x is shown in figure 3.2. So here we have force, first of all 1.4 newtons, and then force decreases to 0.80 newtons, but it stays constant for this period of time, and force also stays constant up to 3 seconds. So if we draw the line, so here we have 3 seconds. Before 3 seconds, force is equal to 1.4 newtons, and after 3 seconds, force is equal to 0.8 newtons. And for this question, we need to define force. What is force? Force simply is equal to rate of change of momentum, means the resultant force, this is equal to rate of change of momentum. And this is very common question, so you need to understand how to define force. So simply we can say force is rate of change of momentum. So we can write down force is rate of change of momentum. And this question has only 1 mark, and this is B mark. If you write down this, you will get 1 mark. For the second part, we need to determine the change in momentum of the block from time t is equal to 0 to t is equal to 3.0 seconds. And net force, we understand that net force is equal to rate of change of momentum. And for this question, we need to determine change in momentum. So the change in momentum is equal to F net times delta t. If you look at this given graph, we can find the applied force from here. Applied force is equal to 1.4 newtons until 3 seconds, means up to this point force applied is 1.4 seconds. Then there is also frictional force that is acting on the block. So the resultant force is applied force minus friction. So we have minus friction, and duration of time is given, that is 3.0. Now simply we can plug in values. We can say delta P in this case is equal to net force, that is 1.4, minus the friction, that is 0.8, multiply by the time we applied force. So beauty of this one is, if you throw something like this, change in momentum will be small, but if you throw something like this, change in momentum will be greater, because you apply the same force for longer time, same net force for the longer time, so change in momentum will be greater. So time is given to us, that is equal to 3 seconds. So if we multiply, we will get 1.8 kgs meters per second. The beauty of physics, physics in action. If you throw something like this, change in momentum will be small if for the same applied force and shorter period of time. And if we apply the same resultant force but for longer period of time, change in momentum will be greater. So that's the reason when we throw something, we throw like this. We not just throw like this. Very important, very practical point. So answer for this question is 1.8 kgs meter per second. So if you have written this equation, you will get 1 C mark, and if you got the right answer, you will get 2 marks. Part B1 says describe and explain the motion of the block between time t is equal to 3.0 seconds and t is equal to 6.0 seconds. So if we look at the force, applied force on the block in this interval of time, applied force is equal to 0.8 newtons. On the block we have applied force x, so we can say this is over x force, and this is equal to 0.8 newtons. And also there is friction, and frictional force F is also equal to 0.8 newtons. It simply means that resultant force on the block is equal to 0. So as resultant force is 0, we can write on here as resultant force is 0 on the block is 0. So velocity remains constant. So velocity remains constant. So this is how you can answer. This question has 2 marks. So it has 2 B mark. One for writing resultant force is 0, and second for writing velocity remains constant. Means magnitude and direction of velocity remains constant. Part 2 says force X produces a total power of 2.0 watts when moving the block between time t is equal to 3.0 seconds to time t is equal to 6.0 seconds. Calculate the distance moved by the block during this time interval. So for this one, first thing we need to understand that power is equal to Fv. So from here we can calculate value of V. V will be equal to P divided by F. So we have value of power developed, that is equal to 2.0 watts, and the force between t is equal to 3.0 seconds to t is equal to 6.0 seconds. Applied force is equal to 0.8. So we can calculate value of V. So value of V in this case will be equal to 2.5 meters per second. Now we have value of V, and the block is moving at a constant speed because there is no resultant force. So simply we can say distance has to be equal to V times t, because speed is constant. So speed is 2.5 and the time interval is 3.0 seconds. So the final answer has to be equal to 7.5 meters. So this is how we can answer. So simply we can say final answer is 7.5 meters. And this question has 3 marks. So the first mark will be for writing this formula, C1 mark, and the second C1 mark will be for calculating value of V, and the final mark will be the answer mark. Part C says the block is at rest at time t is equal to 0. On figure 3.3, sketch a graph to show the variation of the momentum of the block with time t from time t is equal to 0 to t is equal to 6.0 seconds. Numerical values of momentum are not required. For this question, first thing we need to understand, we have momentum on y-axis and we have time on x-axis. So the gradient of this one, so the gradient of this graph has to be equal to delta p by delta t, and this gradient is representing net force. For this question we need to understand, for interval from t is equal to 0 to t is equal to 3 seconds, we have x that is equal to 1.4 seconds. So we can say t is equal to 0 to t is equal to 3.0 seconds, and the net force we have for this interval of time, that will be equal to 1.4 minus 0.8 friction, so that will be equal to 0.6 newtons. And for interval we can write down for t is equal to 3.0 to 6.0 second, F net is equal to 0. So it means that in the first interval, gradient has to be equal to 0.6. Gradient has to be equal to this one, and in the second interval, gradient has to be 0. Gradient has to be 0. And for this question, we don't need any numerical values. So simply we can sketch this one. We can start from origin because initial momentum is 0, because initial velocity is 0. So up to 3 seconds. So we have 3 seconds here, up to 3 seconds. Gradient has to be constant because resultant force is constant. And after that, resultant force is 0. So the gradient has to be 0. So this is how we can sketch the graph. Question 4 says a spring is suspended from a fixed point at one end. The spring is extended by a vertical force applied to the other end. The variation of the applied force with the length capital L of the spring is shown in figure 4.1. For the spring, state the name of the law that gives the relationship between force and extension. So that is Hooke's law. Pretty straightforward question is asking you to write down name of the law, and name of the law is Hooke's law, mean F is directly proportional to minus X. So this law is Hooke's law. And this question has only 1 mark. If you have written Hooke's law, you will get 1 B mark. Part B says determine the spring constant in newtons per meter, and spring constant K is equal to force divided by extension delta X, or simply for this graph we can say it is also equal to the gradient of this graph. So simply we need to calculate the gradient. We will be taking this point and we will also consider this point. So the force in this case, we have 12. This is 12.0 minus 0 force divided by, we have maximum extension, that is 24 centimeters, minus we have the initial length, that is equal to 8, but the units for this one is centimeters, so we have to convert into meters. And now if we solve this one, our final answer up to 2SF has to be equal to 75 newtons per meter. So this one is the final answer. And this question has 2 marks. The first mark you will get if you have written this one, so this one will be 1 C mark, and the second mark should be the answer mark. Part C says determine the elastic tension energy when F is equal to 6.0 newtons. So first of all, it is given to us that F is equal to 6.0 newtons. And from here we can find the extension. So from here we can find out extension. We need to calculate in this case delta EPE, means the change in elastic tension energy, and change in elastic tension energy will be equal to the work done by applied force, and work done by applied force will be equal to the average force, because in this case force is not constant, times distance. So F average we can write down, this will be equal to F max plus 0 divided by 2, because force started from 0, times distance d. Distance d will be equal to x, means equal to delta x extension. So this is our extension. So simply we can write on here, we have 1/2 F max times we have delta x, and value of F max we have, that is equal to 6.0 newtons, and we can find out delta x 16 minus 8. 16 minus 8, it means we will get 8.0, and this will be multiplied with 10 to minus 2, because this is given in centimeters. So if we solve this one, our final answer will be equal to 0.24 joules. So this is the final answer. And this question has 2 marks. The first mark you will get, that one will be the C mark. If you have written this equation, means this one if you have written, you will get 1 mark, and this one will be the answer mark. If you got the right answer, you will get 2 marks for this question. That's all for this video, and we have discussed all questions about mechanics in today's lesson. And in the next lesson, we will discuss remaining questions about waves, electricity, and radioactivity from this paper. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 2, Variant 2. In the last two videos, we have already discussed from question 1 to question 4, means we have discussed all questions about mechanics in the last two videos. And today's lesson, we will start from question number 5, and question 5 is about waves. Then we will discuss about electricity, and finally we will also discuss about radioactivity. It simply means that we will cover all the remaining questions from this paper in today's lesson. So this lesson is very important because most of the time students they struggle with waves, and today's lesson is very important to improve your understanding of waves and polarization. As always we will discuss these questions in detail so you can improve your conceptual understanding of AS physics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 5, part A says, a progressive wave travels through a medium. The wave causes a particle of the medium to vibrate along a line P. The energy of the wave propagates along a line Q. Compare directions of lines P and Q if the wave is a transverse wave and if the wave is a longitudinal wave. So first of all, for transverse wave, imagine that wave is traveling to the right. So this is direction of wave, or we can say this is direction of energy transfer, and this is represented by Q. Now imagine that we have a medium particle, and this medium particle, due to transverse wave, this will be vibrating up and down, means it will go up and it will go down. So this is represented by line P. Question is asking us compare directions. So simply if you look at the angle between these two lines, angle is 90 degrees. It means these two lines are perpendicular to each other. So simply we can say perpendicular. So these two lines are perpendicular to each other. So we can say perpendicular to each other. So the angle between them is 90 degrees. Now if you look at longitudinal waves, again imagine that we have a wave, longitudinal wave. This is moving to the right. So this is direction of wave. So this is represented by Q, and now we can imagine that we have a medium particle. So here we have a medium particle, and this medium particle will vibrate to the left and to the right. So this will vibrate to and fro in this direction. So this is how particle will vibrate. So now if you look at these two lines are parallel to each other. So simply we can say these two lines are parallel to each other. So simply we can say parallel to each other, parallel to each other. So these two lines are parallel to each other. So this is what we need to write down, and here we have P that is perpendicular to Q, and here these lines are parallel to each other. And this question has 2 marks. If you have written these 2 points, you will get 2 B marks. Part B says a tube is closed at one end and a loudspeaker is placed near the other end of the tube as shown in figure 5.1. The loudspeaker emits sound of frequency 1.7 kHz. The speed of the sound in the air in the tube is 340 meters per second. A stationary wave is formed with an antinode A at the open end of the tube. There is only one other antinode A inside the tube as shown in figure 5.1. So we have one antinode here and we have another antinode here. For this question we need to determine wavelength of the sound. Wavelength of the sound. We have the frequency, we have the speed. So simply we can write down lambda, this is equal to V over F. So we have value of V that is equal to 340 meters per second, and the frequency is 1.7 kilohertz. And now if we solve this one, we will get our answer up to 2SF 0.20 meters. So the answer is 0.20 meters. So this is how you can answer. This question has 2 marks. So the first mark you will get if you have written this formula, you will get 1 C mark, and the second mark will be the answer mark. For the second part, we need to determine the length capital L of the tube. But for this question, it is given to us we have antinode at one end and then also an other antinode is given. So at the closed end there must be one node, and halfway between these two antinodes there must be another node. So halfway, so at this point there will be another node, so we can also label this one is node. So here we have antinode, so the amplitude is the maximum, and then amplitude has to be 0 here, and then amplitude has to be maximum here, then again it has to be 0 here, and then we can sketch amplitude here has to be maximum, it has to be 0, and then it has to be maximum at antinode. So this is the rough sketch how the wave inside this tube will look like. In order to answer this question, we also need to understand the distance between consecutive node and antinode is equal to lambda by 4. So here we have antinode and also we have node. So the distance between node and consecutive antinode is lambda by 4. So here we have node and antinode. So this distance is also equal to lambda by 4. So simply we can say in this case L is equal to 3 times lambda by 4. So we can write down 3 by 4 times lambda we have already calculated, that was equal to 0.20. Now if we multiply this one, we will get 0.15 meters. So this is value of L. L is equal to 0.15 meters. So if we got the right answer, we will get 1 mark. Third part says the maximum wavelength of the sound from the loudspeaker that can produce a stationary wave in the tube. So we need to determine the maximum wavelength, and maximum wavelength is possible when we have antinode at the open end and we have only one node at the closed end. Now if we sketch the stationary wave, it should look like this. So it should look like this. It's just a rough sketch, not very good looking, but at least it can give you some idea how you need to sketch the first harmonic in this tube. So it should look like this. So this is how you need to sketch. So this is the maximum wavelength. So in this case you can see we have only one antinode and we have only one node. So the distance between these two consecutive node and antinode has to be equal to lambda by 4. So simply we can say in this case L is equal to lambda by 4. So from here we can say lambda max, this has to be equal to 4 times L, and value of L we have just calculated, that was equal to 0.15 meters. So if we multiply this one, we will get 0.60 meters. And this question has only 1 mark. If you have got the right answer, you will get 1 A mark. Part C says two polarizing filters are arranged so that their planes are vertical and parallel. The first filter has its transmission axis at an angle of 35 degrees to the vertical, and the second filter has its transmission axis at an angle alpha to the vertical, as shown in figure 5.2. Angle alpha is greater than 35 degrees and less than 90 degrees. A beam of vertically polarized light of intensity 8.5 watts per square meter is incident normally on the first filter. For part C1, show that intensity of the light transmitted by the first filter is 5.7 watts per square meter. So for this question, first of all, it is given to us this light is vertically polarized. Mean here we have first of all vertically polarized light, so we can draw this arrow here. So we have vertically polarized light. We can also say the intensity of this one is I naught, and I naught is equal to 8.5 watts per square meter. And for this question we need to determine intensity I1, transmitted intensity. So simply we can write down Malice's law. I transmitted means I1, this one has to be equal to I naught cosine square theta, cosine square theta, and theta is the angle between two filters, mean between vertically polarized light and between this first filter. So the angle between these two, this is the angle between vertically polarized light. So we have vertically polarized light, and the angle here we have 35 degrees. So angle between these two. So in this case simply we have I naught first of all, that is 8.5, and we have cosine, and theta in this case is 35. So we have 35 degrees and square of this. And if we solve this one, our answer should be equal to 5.7 watts per square meter. So this angle you have to take between transmission axis of first filter and vertically polarized light. So means this one is our transmission axis now, and the light is vertically polarized. So the angle between these two we have to take, and then we need to take square of that angle, cosine square of that angle, and we can find out our final answer. So in this case, this is our final answer, and this question has only 1 mark, so this one has to be a mark. Second part says the intensity of the light transmitted by the second filter is 5.2 watts per square meter. Calculate angle alpha. We have already discussed this intensity is I naught, and here we have intensity I1, and I1 we have just calculated in the first part. I1 was equal to 5.7 watts per square meter. Now we need to find out value of this angle alpha, and alpha is the angle from vertical. So we can draw first of all an other arrow here. This arrow is representing angle of 35 degrees. So this angle is 35 degrees with vertical. We can say this angle is theta. So in this case, alpha, this will be equal to theta plus 35 degrees. So now simply we need to find out value of theta. In order to find value of theta, we can write down I2. So here we have intensity, transmitted intensity I2. This one has to be equal to I1 times cosine square theta. Cosine square theta. I2 we have, and I2 is equal to 5.2 watts per square meter. Now simply we need to plug in values, and we can calculate value of theta. I2 is 5.2, I1 is 5.7, and here we have cosine square theta. So from here we can write down cosine square theta. This will be equal to 5.2 divided by 5.7. Then we can take square root on both sides. We will get 5.2 divided by 5.7 root of this one, and from here then we can determine value of theta. Theta will be equal to cosine inverse 5.2 divided by 5.7 root of this. So if we solve this one, we will get theta is equal to 17 degrees. So alpha from here will be equal to 17 plus 35 degrees. So the final value of alpha has to be 52 degrees. So this is how we can answer this question. And this question has 2 marks if you got the right answer. If you have got this right value, and if you have got this right value, you will get 2 marks. Question 6 part A says the current in the lamp decreases. State and explain how the resistance of the lamp changes. For this question, it is given to us temperature of the lamp decreases. If temperature of the lamp decreases, it means speed of electrons also decreases, because electrons have less kinetic energy. As speed of electrons decreases, it also means that the number of collisions between ions and electrons also decrease. It simply means that resistance of the lamp decreases. So simply we can say as temperature decreases, as temperature decreases, resistance also decreases. Temperature decreases, resistance also decreases. This is true for filament lamp. This question has only 1 mark, and this should be B mark. Part B says a cylindrical wire has length capital L and resistance capital R. The total number of free electrons contained in the volume of the wire is capital N. Each free electron has charge small e. The potential difference between the ends of the wire is capital V. Determine expressions in terms of sum or all of the symbols for the current in the wire. So for this question, it is given to us, we have a wire. So you can just imagine this is one wire. and current passing through this wire, we have to determine the current passing through this wire, and the resistance of this wire is given to us, that is equal to capital R. And if we connect a voltmeter across the ends of this wire, the value of PD is also given to us. So value of PD we have, that is equal to V. So we need to determine value of I. So I simply is equal to the potential difference across the ends of the wire divided by the resistance of the wire. So that's all what you need to write down. And this question has only 1 mark. If you got the right answer, you will get 1 mark. Pretty straightforward question. For the second part, we need to determine the average drift speed of the free electron. So simply we need to use transport equation. I is equal to NQVA. We need to determine the average drift speed, so we can make V the subject. So this is equal to I divided by NQA. But if you look at the given informations, it is given to us that we have the volume of the wire, and we have the total number of free electrons in the wire, and each electron has charge E, and we have the total resistance of the wire. So I, first of all, we can write down I, we have already determined. So I is equal to simply V divided by R. And we have N, so N, we can say that N is the number of free electrons per unit volume. So we have the total number of free electrons, total number of charge carriers divided by volume of the wire. So this is the number density, and Q in this case is equal to E. So we left with A, cross-sectional area of this wire. Cross-sectional area of this wire means the volume V. This has to be equal to the cross-sectional area of the wire times the length of the wire. So simply we can draw. So this is our cylindrical wire. This is like a cylinder. So we can imagine its cross-sectional area is A, and the length of the wire we have, that is equal to capital L. So A, from here we can write down, this is V divided by L. So this is over A. Now simply we need to plug in these values and we can get the answer. So we have I, first of all, I is equal to V divided by R. So this is. Then we have N. N is equal to capital N divided by V. And we have A, that is equal to V divided by L. And we have Q. Q is equal to small e. Now we can simplify this one. Now simply we need to simplify. So this V we can cancel with this V. So we left with, here we have V. This is the potential difference. This is volume. This is also volume. So we can cancel, but we cannot cancel. So we can write down V divided by R, and this is divided by, we have N times E, and this is divided by L. So if we simplify this one, we can say this is V divided by R capital N E, and here we have L. So this is the average drift speed. And so this is our final answer. Simply you need to understand I is equal to which quantities, N is equal to what, and A is equal to what, and then simply put in transport equation, and you can find out value of drift speed. And this question has 2 marks. If you have got the right answer, you will get 2 marks. Third part says determine the average time taken for a free electron to move along the full length of the wire. So first of all, we can simply draw this one small cylinder, and this small cylinder is representing wire, and the length of this wire is given to us, that is equal to capital L. And for this question, we can also imagine we have one tiny electron at this face of the cylinder, and how long this tiny electron will take to reach the other end of the cylinder. So we need to determine the time taken. So we can say delta T. This is what we need to determine. But for this question, we have already determined average drift speed of free electron. That was equal to VL divided by, we have R capital N E. So now we have distance, we have speed. So time delta t simply will be equal to distance divided by Vd, speed. So we can write down, we have L, and this is divided by VL divided by N capital RE. So from here we can cancel this L with this. So we left with capital N capital R E divided by the potential difference. So this is our final answer. So this is time. So if we have value of capital N, we have value of capital R, we have value of E, and we have value of PD, we can determine the time taken by a free electron. And this question has only 1 mark. So if you have got the right answer, you will get 1 mark. Question 7 part A says a battery of electromotive force 9.0 volts and negligible internal resistance is connected to a light dependent resistor and a fixed resistor as shown in figure 7.1. The LDR and fixed resistor have resistance of 1800 ohms and 1200 ohms respectively. Calculate the potential difference across the LDR. So this one is our LDR, light dependent resistor. We need to determine the potential difference across LDR. So we can say this PD is V1. So if you look at this circuit, imagine that current I naught is coming from the power supply. So this is the total current in the circuit, and current passing through this LDR is also the same. So we can compare I total, this is equal to the current passing through LDR, and total current in the circuit, we can simply say the EMF divided by the total resistance in the circuit, that is equal to 1800 plus 1200. One has to be equal to V1 divided by the resistance of this resistor, that is equal to 1800 ohms. Now we need value of V1 from here. So V1 simply will be equal to 9 times 1800 divided by 1800 plus 1200. So if we solve this one, we will get V1 is equal to 5.4 volts. So the final answer for this question is 5.4 volts. So a beautiful way you can answer like this. Most of the time we remember that is resistance of LDR divided by R total resistance in the circuit, and this is only true if resistors are connected in series, multiply by EMF of the power supply, means V0. Simply you can understand I is the same, total current is equal to the current passing through the LDR. So we can equate these currents and we can derive this one. So this is our final answer. This question has 2 marks, so you will get 1 mark if you have written this one. That one has to be the C mark, and the final mark you will get, that is answer mark, and if you have got the right answer, you will get 2 marks. Part B says the circuit in A is now modified by adding a uniform resistance wire XY and a galvanometer as shown in figure 7.2. The length of the wire XY is 1.2 meters. The movable connection Z is positioned on the wire XY so that the galvanometer reading is 0, means the reading on this galvanometer is equal to 0. We need to calculate length XZ along the resistance wire. As reading here is equal to 0, it means that the PD between XZ, so we can draw voltmeter here, PD across XZ is the same as PD across LDR. And PD across LDR we have already determined that was equal to 5.4 volts. So it means reading on this one is also 5.4 volts. We can also imagine a voltmeter that is connected. We can connect here. Let's say this is V0. This is connected between these 2 points, X and Y. And the reading on this voltmeter has to be equal to 9.0 volts. As there is no current in this wire, it means the current passing through XZ is the same as the current passing through XY, means current in this whole wire is the same. Current is the same. So simply we can say current passing through XZ, this one is equal to current passing through XY, as no current is entering from this branch. So the current across this one we can simply find out by writing out potential difference across this one, that is equal to 5.4 divided by resistance of this part of the wire. We can say resistance XC. And here we have IXY, so that is equal to 9.0 resistance of the wire XY. Now from here we can write down this is 5.4 divided by resistance of this part of the wire, that will be equal to rho LXZ divided by A. And here we have this is 9.0 and this is divided by rho and LXY divided by A. From here you can see this rho we can cancel with this A we can cancel with this. So now simply we left with 5.4 divided by LXZ. This is equal to 9.0 divided by LXY. LXY is equal to 1.2. So this is 1.2. So now simply we can find out LXZ. LXZ will be equal to 5.4 times 1.2 divided by 9, and if we solve this one, our final answer has to be equal to 0.72 meters. So this is LXZ. I have explained you this one in detail so you can have better understanding of this one. Why do we use this formula? Otherwise simply I can start from here, I can plug in values and I can find the answer. So this is a way you need to understand why we did like this. Current, as current is the same in the wire, so then we can write down current is equal to V by R, and then we can solve to get the value of XC. And this question has 2 marks. The first mark you will get C1 mark if you have written this step, and if you have got the right answer you will get 2 marks. So final answer is 0.72. Second part says the environmental conditions change causing a decrease in the resistance of the LDR. The temperature of the LDR remains constant state whether there is a decrease, increase or no change to the intensity of the light illuminating the LDR. So it is given to us that resistance of LDR decreases. If resistance of LDR decrease, it means intensity of the light should increase. Intensity of the light illuminating the LDR means the light falling on LDR. Intensity of that light has to increase. So simply we can say intensity increases. It's a very important point. You need to understand how intensity and resistance, they are linked with each other. So intensity increases, simply we can write on here. The total power produced by the battery. Now in this case resistance of LDR decreases, so it means the total resistance of the circuit decreases. So we can say the I total, this is equal to 9.0 divided by total resistance. As total resistance of the circuit will decrease, it means current will increase. So as current increases, so we can say power, this is equal to I square times R. So current in this case increases, so the power produced by the battery will also increase. So we will say power increases. So we will say power increases because more current is coming from the battery. So battery is giving more energy to the charges per second. So power increases. The length XC, so that the galvanometer reads 0. So how this length will change? So if this resistance decrease, it means that the reading on the voltmeter, so we can connect voltmeter here V1, this reading also has to decrease because the reading here, if we connect a voltmeter, let's say here we have V2, reading on this voltmeter has to increase. So this reading has to increase and this reading has to decrease because the sum of these two PDs is equal to 9.0. So the PD across this one decreased. So if we connect voltmeter here, let's say V1, so the PD across XC also decreases. So the length has to decrease because V is equal to I times resistance. So we can also say this is I times rho L by A. So if this is constant, this is constant. So if V decreases, this V decreases, L also has to decrease. So we will say in this case XC decreases. So XC decreases. So XC has to decrease because V1 has been decreased. So this is how we can answer these questions. And this question has 3 marks. So if you have done the first one, you have written intensity increases, you will get 1 B mark. And if you have written power increases, you will get another B mark. And you will get another B mark if you have written XC decreases, because PD across XC decreases. Question 8, part A says nucleus P and nucleus Q are isotopes of the same element. Nucleus Q is unstable and emits a beta minus particle to form nucleus R. For nuclei P and Q, compare the number of protons. As P and Q, they are isotopes of the same element, so they should have the same number of protons, or we can say equal number of protons. And the number of neutrons, they should have different number of neutrons, or simply you can say unequal number of protons. Part 2 says when nucleus Q decays to form nucleus R, the quark composition of a nucleon changes. State the change to the quark composition of the nucleon. We have nucleus Q. It decays into nucleus R by emitting beta minus particle. If beta minus particle is emitted, then there must be electron anti-neutrino as well. Now we can assume atomic number of Q is C, mass number is A. So the atomic number of R has to be C plus 1 because charge has to be conserved in any decay, and mass number will be A. So Z is representing number of protons, and here we have Z plus 1 mean number of proton increase. It simply means that one neutron decays into one proton. And quark composition of neutron is 1 up quark and it has 2 down quarks. And proton has 1 down quark and it has 2 up quarks. So if we compare the quark composition, so this one is the same. So 1 up quark, 1 down quark. So it means this one is the same. Now here we have D and here we have U, means here we have down quark and here we have 1 up quark. It simply means that 1 down quark decays into 1 up quark. So simply we can say down quark decays to up quark. And for the last part, we need to state the name of another particle, not the number, that must be emitted from nucleus Q in addition to the beta minus particle, and that particle is electron anti-neutrino. So simply we can say another particle is electron anti-neutrino. So this is an other particle. So if you write on these points, you will get 4 marks for this part of the question. Part B says a hadron consists of 2 charm quarks and 1 bottom quark. Determine in terms of the elementary charge small e the charge of the hadron. So first of all, we need to understand the charge on the charm quark. So simply we can write down charm quark. Charge on charm quark is plus 2 by 3e, and charge on the bottom quark, so we can also write on here charge on bottom quark, this is minus 1 over 3e. Now we need to determine the charge on hadron, so we can say Q, the total charge on the hadron, this one has to be equal to 2 times the charge on 1 charm quark plus charge on 1 bottom quark. Now if we multiply, we will get here 4 by 3e minus 1 over 3e, and if we solve this one, we will get plus 1e. So if you have proved this one, you will get 2 marks, and this question has 2 marks. That's all for today's lesson, and we have discussed all the questions from this paper. If this video was helpful, please like and subscribe because your encouragement is very important. And also, if you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. See you in next video.